Let's walk through Kerberos, Radius, and 802.1x, because these are some of the most commonly confused authentication and network access concepts on the Security Plus exam. The confusion happens because all three involve authentication, but they do very different jobs. The key is understanding. Who is being authenticated? What is controlling access? And where the authentication is happening. We'll begin with Kerberos, because this is primarily an identity authentication protocol. If a scenario describes users logging into a domain environment and receiving secure authentication without repeatedly sending passwords across the network, you are dealing with Kerberos. Kerberos is a ticket-based authentication protocol commonly used in Windows Active Directory environments. The key purpose of Kerberos is securely verifying user identity. For example, imagine an employee named Sarah logs into her company Windows laptop in the morning. After entering her username and password once, Kerberos provides authentication tickets that allow her to access email, file servers, printers, internal applications, without typing her password repeatedly. Instead of constantly sending passwords across the network, Kerberos uses tickets to prove identity securely. A common exam trap is confusing Kerberos with general network access control. Kerberos does not decide whether devices can connect to the network. Kerberos focuses on verifying user identity inside the environment. Now let's transition into Radius, because this is where centralized network authentication begins. If the question describes centralized authentication for wireless access, VPN access, or remote network connectivity, you are likely dealing with Remote Authentication Dial-In User Service, or Radius. Radius centralizes authentication decisions for network access. For example, imagine employees connecting to the company Wi-Fi network. Instead of every wireless access point storing usernames and passwords locally, all authentication requests are forwarded to a central Radius server. The Radius server checks the credentials and decides whether access should be allowed. This creates centralized authentication management across the organization. Radius is extremely common for enterprise Wi-Fi, VPN authentication, network access control. Now let's compare Kerberos and Radius directly, because this distinction is heavily tested. Kerberos authenticates users inside domain environments using tickets. Radius centralizes authentication for network access requests. The easiest way to remember the difference is Kerberos helps users prove identity. Radius helps networks decide whether access should be granted. Now let's move into 802.1x, because this is where many students finally understand how everything connects together. If the scenario describes devices being blocked from network access until authentication succeeds, you are dealing with 802.1x. 802.1x is a port-based network access control standard. The key purpose of 802.1x is controlling whether devices are allowed onto the network at all. For example, imagine an employee plugs a laptop into an office network jack. Before the device can communicate on the network, 802.1x requires authentication to occur first. If authentication succeeds, the port opens and network access is granted. If authentication fails, the device is blocked. The key phrase to recognize is authentication before network access. A common trap is assuming 802.1x performs the authentication itself. It does not. 802.1x is the enforcement mechanism controlling access to the network. This is where the relationship between all three technologies becomes important. Here's a real-world example showing how they can work together. An employee arrives at the office and connects their laptop to the corporate Wi-Fi. First, 802.1x prevents the device from accessing the network until authentication occurs. Next, the wireless access point forwards the authentication request to a Radius server. Then, the Radius server validates the user credentials. Finally, after the user gains network access, Kerberos may authenticate the employee inside the Windows domain so they can securely access company resources. That sequence is extremely important. 802.1x controls access. Radius centralizes authentication. Kerberos verifies domain identity. Now let's go one step deeper with another comparison. Imagine a hacker plugs an unauthorized device into the corporate network. 802.1x can block the device before any access occurs. If the attacker attempts to connect through enterprise Wi-Fi, Radius may reject the authentication request centrally. And even if the attacker somehow gains limited network access, Kerberos still protects domain resources by requiring valid authentication tickets. Each technology protects a different layer of access. Now let's bring everything together using recognition patterns. If the question describes ticket-based authentication inside a Windows domain, think Kerberos. If it describes centralized authentication for VPNs or enterprise Wi-Fi, think Radius. If the scenario focuses on devices being authenticated before network access is allowed, think 802.1x. And if the technologies appear together, remember the layered relationship. 802.1x controls access to the network. Radius handles centralized authentication. Kerberos authenticates users inside the domain. The most important takeaway is understanding that these technologies are complementary, not competing. Kerberos focuses on identity authentication. Radius focuses on centralized network authentication. 802.1x focuses on controlling access to the network itself. If you can recognize those distinctions and connect them to real-world enterprise environments, like corporate Wi-Fi, VPN access, and Windows domains, you'll be able to eliminate incorrect answers quickly and confidently identify the correct concept on the exam.